Basic probability. Basic probability. All right, how do I find the probability of a given event? Ready? Please.
Please. Thank you.
All right, let's talk about an independent event. First of all, what does it mean to be independent?
To yourself. Alone by yourself.
To yourself?
Yeah. No. To yourself.
What does independent mean?
I'm independent.
By yourself. What is? No, you're not.
Yeah.
Self-sufficient means you pay for your own what? Rent. Your own what?
Oh.
Bills, your food, your lights over your head, like your insurance, your phone, your car insurance, all of those things. Not.
Pay for my own bills.
Not all of them. There's no way. It's expensive. Sometimes I wish I didn't. What?
My dad gave me a slaw. Mr. Donald Trump is a rich white boy.
What does that have to do with independent? Alright, it also says if the occurrence, so remember independent is like all by itself, right? The occurrence of one has no effect on the occurrence of another. So yeah, it's a little different, but independent is all by itself. We don't depend on anyone else or anything else. So if the occurrence of one has no effect on the occurrence of another. So completely alone, minding its own business. Okay. Example 1. So I have this bucket of candy. You're not getting candy. And my bucket consists of 3 different types. Skittles, Starburst, and Snickers. Yes, you're kicking her. Stop.
Oh, shoot. Sorry. I didn't hear efforts.
He like did it again to make sure he was like, oh wait, am I really kicking her? What is this thing I feel? Her leg. In my bucket of candy, there's a bag of Skittles, Starburst, Skittles, Starburst, Snickers, Starburst, Snickers, oops, Snickers, 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 Starburst, Snickers, Snickers, Skittles, Starburst, and Snickers. I'll let you write those out.
Well, can we just put like...
Okay, here we go. How many total pieces of candy are in the bucket? How many total pieces of candy are in the buckets? We're not going to answer just yet. We're going to write out the problems. Next question. What is the total probability of selecting a Skittles from the bucket? Letter C. Pretty much asking the same question as letter B, except for we're not going to ask about Skittles. I'm going to ask about a different one. So instead of, we can rewrite what is the total probability of selecting a Starburst from the bucket, or Snickers. Okay, so I'm just going to say probability of Snickers. Because I don't want to write out the whole question. I could, but I don't feel like it. And letter D, probability of what? Starburst. So it's the same question as letter B. Yes. Favorite kind of candy? More chocolate. Reese's peanut butter cup, but they have to be cold. Right. Snickers, Twix. Those are good. I haven't had that in a long time. All right, ready? Let's answer these questions. Here we go. First question, it says, how many total pieces of candy are in the bucket? I don't know. Count them. How many? 16. Double check somebody.
Yeah, 16.
Okay. 12.
I got 16.
Okay, good. I may have some, but I don't know. All right, it says, letter B, what is the total probability of selecting the Skittles from the bucket? So you're going to say probability of what? P stands for probability. It's a different P than yesterday. Yesterday was NPR. That was permutation, correct? Today is not permutation, today is probability. So it starts with P right away. In parentheses, we usually put what we're talking about. Whether it's one letter or two, we were talking about Skittles, good luck. We're talking about Skittles, so all of them start with S, so I don't want to use S, we'll use S-K. Make sense? So we're asking, what is the probability I reach my hand into the bucket, I'm going to pull out a bag of Skittles. Does that make sense? Okay, so how many Skittles are in the bucket?
Skittles, let me see.
3. Out of what's the total of in the bucket? 16. Do you understand what we're doing?
Yes.
Okay, so how many Skittles are in the bucket? 3 out of 16. This is going to give me a percentage of what is the likelihood of me pulling out that Skittle. Do you see how that works? Okay, so we're going to get 3 out of 16. Now, remember the other day on Monday I said, hey, for every answer you're going to give me what? A fraction, a decimal, and then a percent. So guess what I need now? A decimal. Your decimal I rounded to the nearest? 100th. Your percent I want to the nearest what? Very good. So what do you need to do?
Get a calculator.
Okay. He doesn't appear to be crippled.
Oh no, yeah, I need your.
Oh.
No. Yeah. I got you. Surgery's no fun. Well, I got it.
Watch the cords. Push that thing back for me, please, somebody. Like, carefully. There we go. Before someone's phone falls. All right, so find out what your decimal is and what your percent is. Round it correctly.
How do you find it again?
Hold on. I was going to tell him to go back to the notes from the other day.
Oh, yeah, go back to the notes. No,
Aren't they in your notebook?
Got it.
Didn't I give you a notebook that day?
Yes.
Okay. Okay, check with someone next to you. Make sure you round it correctly for the decimal and the percent.
Yo, no, wait, I got the exact same.
You didn't do it yet? Okay.
What's so?
Great stuff. So I just write down the answer? Just write down the answer?
Yeah. Yeah. All right. What do we get for 3 over 16 as a decimal?
0.18.
Round it correctly, please.
18.7.
Round it correctly, please. 0.19. Why is it 19? Because it's 7 after that. Why are you two over there talking still?
Yeah, why?
What's our percent? TJ, shush. TJ. Stop it. Bless me. Here we go. You take what's in the calculator. The calculator still has a decimal, correct? You multiply that by 100. Then you give me my percent. What is my percent? 18 point what? Is it 7? What's after the 7? So is it 18.7 or 18.8?
Yeah, that's your calculator.
Maybe they're pushing the wrong button.
Or you didn't round it right. Alright, probability of Snickers, go. What do you want to call Snickers? Probability of what? SN is a good one. You what? You don't think so? I don't think so either. Alright, probability of Snickers is what?
0.5.
How about the fraction first?
8 over 16.
Should be 8. Easy miscounted. It's 8. 8 over 16. 8 over 16 reduces to what?
0.5.
Reduces to what? Reduces to what? 1/2. Thank you.
Hey, nice, Victor.
Because remember, you have to give me a reduced fraction.
No.
TJ. Then you give me a decimal. What's the decimal?
Wait, what?
0.50.
Are you sure it's 8?
Yeah, it is. It's 8. Then you give me a percent.
50.
50.
Got it.
Point what? 0%. Did you get the last one? There's 8.
It is 8.
No, there's 1, 2, 3, 4, 5, 6, 7, 8. Dude, probability of what? ST. Right here, there's 1, 2, 3, 4. You only have 1, 2, 3. Hate when that happens.
Also, like, do have 3 Skittles?
Alright, what's the probability of Starbucks? Starburst, not Starbucks, sorry.
4 out of 16.
4 out of 16? 4? It can't be. 5. There's 3 here. There's 8 here. That's 11. We have 5 left. 5 out of 16, which is what as a decimal? Come on, calculate, people. 0.31. What is that as a percent? Very good. Make sense? All right, let's keep going. Other questions? Okay, you need to make sure you can count. That's the main thing. Also, look at really quick. If you look, we're out of 16, correct? There's only 3 types in this problem. If I count 3 and add 8, that's how much?
10 or 11.
11. Add 5 more?
16.
That should all add up to the total.
Wow.
Okay?
That's great.
I know. Fancy that. Here we go. Example 2. Talk about dice. Or one. How many sides are there? There are 6. What are the numbers on each side? 1, 2, 3, 4, 5, 6. Could I have a different die? Could they have told me it's different? Yeah, it could be different. It could be 8 sides, and they can give you the sides. It doesn't really matter. I'm just going to do a basic one right here. Okay? First example. What is the probability of rolling a 4? Go ahead and calculate that. Check with someone when you're done. Not P over 4, P of 4. Yeah.
I know it.
Okay, be quiet. Did you check?
Yep.
Okay.
I linked to
What do we get?
I got 1 out of 6.
1 out of 6. Why?
Because there's 6 sides.
Because it's only 1 4 out of 6 sides. All right. Ouch. So P of 4 is 1 over 6. What is that as a decimal? 0.17. Good. What is that as a percent? No. 16.7%. All right, here we go, second one. What is the probability of not rolling a 1? Think about that. What is the probability of not rolling a 1? You do not know how to write the P of yet? I'll show you in a second. Think about it though. What does it mean to be not? All right, here we go. Not, keyword. So it's probability of 1, but we don't really want 1. We want not 1. See the line above it?
Yes.
We're going to write that, so that's what it means. Okay? Now, what is probability of not getting a 1?
5 out of 6.
It is 5 out of 6. Why 5 out of 6?
Because you're trying not to hit it.
You're trying not to hit 1, and 1 is only one side, so that's 1, so the others are 5. All right, what's the percentage? I mean the decimal, sorry. 0.83, and the percent. 83.3%. Your calculator didn't lie? Or it did? Oh, okay, good. Make sense? All right, third example. We're going to talk about a deck of cards. Shh. Now, for those of you, how many of you actually know what a deck of cards like? Okay.
Well, 60 something?
52.
52?
You should have what you had.
Hey, bro.
All right. For those of you that didn't raise your hand or need a refresher, it is in the algebra, 2 book, on page 690. Or you can actually go buy a deck of cards for like $1 and practice it that way too. Sometimes it's easier to actually manipulate them, right? To actually see them. So, if you take a picture of page 690 in your book, it's a little small things on one of the examples. It looks like it's like this big. I think it's this way. And it has all of the cards listed. Does that make sense? That way you know what it's talking about. I'm going to show you first before we do it.
Down.
Wait, why is it big?
So you can see them.
Oh.
You should play 52 pickup with him.
Right, probably.
You should play 52 pickup.
Well, he thinks it's 60, so we should play 60 card pickup with him. No.
Do it.
All right, so the question's going to ask a certain thing, but first let's talk about the cards. First of all, there are 4.
You're on. No, I said speed.
Yeah, it's another game, fool.
I said speed.
We're not going to play.
Let's play last card.
Let's talk about the different suits. Here we go. We have diamonds. We have clubs. Spades. Sorry, I have clubs in my hand. That's clubs. I have them in my hand.
And then we got heart.
And then we have hearts. Yes?
Mi corazón. Like that heart?
That's mine.
It's nobody's heart. You all have none. Okay, here we go. I did. All right, so we're going to go through one suit. Here we go. We're going to go through diamonds. So there's the ace. There's the 2. Then it goes 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Yes? Okay. So if there's this for here, then they're also for the hearts, also for the clubs, and also for the spades. Does that make sense? Okay. So let's count through this. Some of you know, but we're still going to get in the count. Here we go. Count them for me. There's 1,
1, 2, 3, 10,
4, 5.
I thought I counted number 6, 7, 8, 9, 8, 9, 10, 11, 12, 13.
There are 13 diamonds in the stack, which means there's 13 what?
So 13 times 4, who can do that?
9.
Forgot.
Hey, what if you count the jokes?
The jokers aren't part of the deck.
Why do we count the deck?
No.
You only got 62.
160 apparently. Okay, here we go. So it's going to ask, what is the probability of picking a heart? So I just went through the diamonds. Do they look exactly like the hearts? Yes.
Different shapes.
We're not being literal. Does it look similar? Yes. It's hot in here. So, probability of a heart is what?
1 out of 4.
No, how many? 13 out of 52 first.
Oh.
That's basically one.
Which reduces to what?
1 out of 4.
1 out of 4. Do you have to show work?
That's 25%.
Yes, it is. So you should be able to tell me a decimal without really needing a calculator. 1 out of 4 is what? 0.25, which is now what is a percent?
25%.
25 point what? 0%. Oh,
On dice, I don't get how 0.17 equals 16.7. You do round. It's just math, you know.
because we rounded to the 0.17. I showed you in the calculator.
I know you showed me the calculator. You know how there's more numbers that keep going? You just round that to this number, so it's about 5 and
All right, what's the probability of a 4?
It is, it's just not round. Yeah, it's just the number before, but after it gets round.
This percentage, is that of all the fours or just one?
All the 4. Well, what's the probability of pulling a 4? How many 4s are there?
4. Just 4.
That's 4. It's always. The thing is, like, what's the percent? What is my luck of getting that 4? It doesn't say what kind of 4, right? It just says 4. I could be more specific and I could say a 4 of hearts, then it's different. But I just said a 4. Okay? I want you to solve this one. When you're old, it hurts. What do we get? Probability of a 4 is what? 4 over 52. Did it freeze? Escape it? And then go back in. There you go. So 4 over 52, which is going to reduce to be what? Reduce. 1 over 13. Which is now what is a decimal? 0.08, which is what is a percent? 7.7. Okay. Questions? Your homework is 2 sides. It is going to ask for probability. Now, the reason why we give you the little funny thing ones is because, why? Check your answers. If you get an answer and it doesn't match up at the top somewhere, then you know you're wrong, okay? That's why we do this. Plus, it makes kind of sense. What did I tell you about the slinking?
Oh,
Yes. Yes. Make sure you're writing your summary. You're not getting behind in those.